So I'm really excited to announce our next presenter, Randy Newton. Randy is a retired engineer who hasn't taken a biology course since the mid 1970s, but his love of birds predates the first Earth Day. Randy got hooked around 1970 when he built his first bluebird box, targeting a species that was then in sharp decline and that he had never seen. He nailed his box to a pine tree in Goose Island County Park in La Crosse, Wisconsin, and despite doing almost everything wrong, found a nesting pair of bluebirds and four eggs in his box 3 weeks later. Randy is a strong advocate of Fran Hammerstrom's Birding with a Purpose, making sure his birding activities provide either useful habitat for birds or useful data to researchers. He volunteers for Carpenter Nature Center and habitat restoration, bird banding, apple picking, and other special assignments. He conducts waterfowl and grassland bird surveys for U.S. Fish and Wildlife, volunteers in many ways at the University of Minnesota Raptor Center, participates in Christmas bird counts, and enjoys staffing the MLU booth Ask Us About Birds at the Minnesota State Fair. Today, Randy is going to talk a little bit about bird banding, banding data, and some of his discoveries in analyzing that data.
All right, am I good to go?
Yep, I can hear you loud and clear.
All right, I'm going to see if I can get this thing to work here. All right. Is that coming through okay?
I'm not seeing your presentation. I see though, like your file thing, so you might just need to switch to what page you're sharing.
Or go to sharing the presenter view, because right now we're seeing kind of the behind the scenes with your
All right.
file folder.
Let me, okay, let me see.
And while you're getting ready to share, Joan, they want to know what bird has your favorite feathers while he's getting ready. And it looks like Joan said,
so that golden pheasant that I showed has such an array of different colors and brightness and iridescence. I would love to see that in person. I think a lot of those pheasants, brightly colored pheasants, are from Asia, so you have to go to Asia to see a lot of those feathers.
Great. And then Randy, while you're working on which screen shares, and just so everybody knows, we do practice these ahead of time, and guaranteed things happen on the day of the presentation. So while Randy's working on that, oh, it's looking pretty good there.
That's not going to work. I have to, I'm trying to find where this one should be the one.
Okay.
And
then while you're getting that ready, Joan, when we do owl banding, we actually get to see the porphyrin on the feathers with the black light. So that's a pretty cool thing. I love that you talked about it. Oh, you're looking good, Randy. So yeah, just hit that slideshow thing. Gorgeous.
Did that work? Okay.
Perfect. Thanks, everybody.
And all right, great. So great presentation so far. Yeah, the title of this presentation is Population Insights from an Ancient Practice. And I really just gave it that title because I wanted to bump attendance. What I'm really going to talk about is why citizen science is important. Rob talked about this a little bit earlier. Why banding is important, why it's important in citizen science, and why we should all spend some time, as Sammy said, birding with a purpose. So when I say citizen science, I'm not talking about chasing rare birds for a list. I know a lot of the people on this call enjoy doing that. And it's a great activity, but 50 listers seeing the same bird really does little to contribute to science. Banding, on the other hand, continues to be a core way to contribute data and knowledge to the scientific community. Why one is more citizen science than the other is something that we'll talk about a little bit more in this presentation. Sammy mentioned Fran Hammerstrom. She was Aldo Leopold's only female grad student a long time ago and was one of the first female wildlife biologists in the country. And in one of her books titled Birding with a Purpose, I don't know if you can see that or not, she states that, and she quotes at the start, "Bird watching for me tends to be with a purpose," unquote. And from a very young age, Fran wasn't satisfied seeing and identifying a warbler and just checking it off a list. She needed to know really what they were doing. So as a child, she routinely climbed trees, peered into nests to understand, nesting behavior, breeding behavior, feeding behavior, how they fledged, until she saw patterns developing. And she called that birding with a purpose. In that book, she dedicates it to, quote, rugged, persistent individuals, both amateur and professional, who without pay banned birds to enhance our understanding and further conservation, unquote. So after I retired as an engineer, Fran Hammerstrom's books really spoke to me. So I got involved as an amateur, which I think is still a generous term for my abilities. But birding with a purpose does give me some purpose in my retirement. Today, we're going to look at some banding data from Carpenter Nature Center's Hastings campus. Joan mentioned earlier that Carpenter does banding at Anoka Community College. They do banding in a number of different locations, demonstrations, and also some science projects. But at the Hastings campus, we've been banding continuously every week for more than 45 years. And so all of the insights that we have today will be just banding from that particular banding station. So I'm going to share some data with you and share some of my insights. And I would encourage you to share some of yours as well, maybe in the chat. None of them may be correct, but they will challenge us to think and to speculate and to hypothesize and to experiment. And maybe in the next year or two, or maybe 10 years down the road, some of the things that we learned from this banding data may help us bend the curve for Minnesota birds. And that's what this is all about. Oops. So why we band? Well, banding or ringing of birds dates back to ancient times. Roman soldiers used marked swallows and pigeons to send messages, and many of you know, even during World War II, we used pigeons to send messages. In the Middle Ages, royal falconers, or beginning in the Middle Ages, royal falconers tagged their birds to identify and recover them, to make sure that somebody else didn't take a bird from them. But modern banding really dates to the 19th century. John James Audubon put colored wires on birds at his home in Pennsylvania and found that the eastern phoebes, for example, in the early 1830s, returned year after year to the same breeding sites. They didn't know that before he started doing this marking of birds. But modern banding really dates to about 1899, when Hans Christian Mortensen, who was a Danish ornithologist, initiated systematic banding using aluminum rings. And if you look at this slide in the upper right-hand corner, you'll see some of these aluminum rings, very similar in 1899 to the rings that we use today. 1909, so 10 years after the beginning of this banding with aluminum rings, the American Bird Banding Association was formed. And they started promoting standard practices in banding, how to band, what data to track. They also promoted sharing data among researchers and started the process of licensing banding stations in the US. As early as the 1920s, there were some really active banding stations in Minnesota that banded tens of thousands of birds. Thomas Roberts talks about some of these early banding activities, and he publishes a lot of the results in the Birds of Minnesota, published in 1932, if you're lucky enough to have a copy of that. He talks about these banding stations in a lot of his other publications as well. So he used that data a lot in putting together the first really comprehensive bird book on Minnesota birds. In the 1920s, the U.S. Biological Survey took over administration of banding in the U.S. The current bird banding lab actually resides in the U.S. Geological Survey, but the banding lab maintains the U.S. database on new bands and on reencounters, and they've been managing this for many years. Aluminum bands are still used today, but they've been complemented with things like auxiliary markers, nano tags, radio transmitters, GPS trackers. If you attended the paper session in December, we heard about a lot of those things. Um, um, but the old technology is still important. As banders, we contribute in other ways. We also take feather samples at Carpenter. We take parasite samples off of birds. We at times gather excrement from birds for researchers who use it to do DNA testing. We check for injuries, we check for signs of disease, and we report them to the banding lab. And we also look for and report any dead birds that are found on the property when we're doing banding. The majority of birds that we're getting research on are just tagged with aluminum bands that were originally used 127 years ago. These new technologies are great. They tend to be pretty expensive. And usually the banding teams and the banding data from these aluminum bands help these researchers define projects using some of the advanced technologies. So some of the things that have been accomplished from banding over the years, banding allowed scientists to better understand migration, something that wasn't understood 125 years ago. They allowed scientists to understand site fidelity. They allowed scientists to understand mortality, life expectancy, breeding success, and population trends in birds. They helped scientists understand bird behaviors, and they helped inform management strategies and habitat protection. So things like how many ducks you can harvest in a day or in a season were informed by a lot of the banding work that was done. And it's still used globally in these same ways. But despite all that banding has helped us understand, we've still lost 3 billion birds in the past 50 or 60 years. I think most of you are familiar with that number. So there's a lot more that we can do and a lot more that we can learn and a lot more than we can accomplish. Now, I mentioned re-encounter data. It wasn't until 2022, 113 years after banding really started, that the banding lab put a feature in their database for banders to enter recapture data. And we'll talk a little bit about some recapture data as well. But up until that time, it was only new bands that were tracked. So now we can look at both our historic banding data and at our historic re-encounter data, which can provide a lot of information on our feathered friends. Let's see. Okay, so we're going to talk about some trends. I'm going to present a little banding and recapture data on some common birds. I have a few simple examples, and we'll try to make sure that we stay on track with time, so I might eliminate a few of them as we get closer. We often talk about the 3 billion birds that we've lost in the past 50 or 60 years, but these declines have not been linear and generally can't be closely correlated with one changing variable. Minnesota birds have declined or increased at different rates than continental observations. And what happens in microenvironments can, in a lot of cases, be very different than what we see in statewide or national trends. So we can compare our banding data over the past 45 years to what has happened to populations in North America and what has happened in populations in Minnesota. And we're going to do just that with the first example. All right, so you recognize this species. This is the dark-eyed junco. It's a winter-only visitor in the Twin Cities area. We've lost about 42% of juncos in North America over the past 50 years, or 180 million birds. I just took some pictures from the breeding birds of Minnesota to show what trends they're showing. So you can see here the trend of the juncos over that 50-year period has been pretty sharply declining. We lose about 1.52% per year since 1966, and the Christmas bird count trend is minus 1.3% per year since 1959. So if we look at data from Carpenter Nature Center over the last 45 years, what do you expect we would see? I don't expect you to answer that on the call here, but I expected that we would see a downward trend, maybe not quite as severe, but certainly a downward trend in that time period. But when I looked at the data, the 45 years worth of data, I see something very different and actually pretty encouraging. Carpenter has had very consistent habitat over the last 45 years. We have been consistent in banding. As I said, we band every week, year round. But as opposed to the data that we saw for juncos in Minnesota and juncos in North America, we have not seen any statistically significant downward trend in these birds. In fact, it's been very, very steady. So what's happening here? Well, we can probably say that habitat matters. We know that habitat loss results in a high preference for available habitat and may even result in crowding in locations that haven't changed, like the place where we banded Carpenter. We might speculate that warmer winters mean more overwintering juncos in the northern part of the winter range, and we are in the northern part of the winter range. Perhaps fewer birds go further south in the winter because Minnesota winters are more amenable to them at this point in time. And so I'd like to know what your theory is. Do these things ring true? Is there enough data here that we could design an experiment to try to figure out why we haven't seen the same downward trends in this microhabitat that we've seen in the state and nationally? Another example, the downy woodpecker. Everybody knows the downy woodpecker. It's a year-round resident, so different from the junco, which is just a winter species here. The breeding bird estimates show the population kind of oddly increasing with a peak in about 1987. And then it dipped more than 10% by 1993 and then rebounded by 2002. But since 2002, the population has dropped all the way back to 1970 levels. In fact, we see a decline by year that's estimated to be 3.8% for the last 15 years, which is really a shocking declining number. So what would you expect we would see at our banding station in Hastings? Well, what we've seen is that probably because of consistent habitat and consistency in banding, we don't see any statistically significant downward trend. In fact, the trend that we see in downy woodpeckers is increasing. So why would that be? Well, again, habitat matters, especially availability of native insects. Downy woodpeckers live their entire life in one area, so I think to the downy woodpeckers that we see today, their parents, their grandparents, their great-grandparents, for many, many, many generations have not experienced any habitat change or any significant habitat change. And as a result of that, our population has stayed consistent or continued to rise. Now, there may be other reasons for that. I'd ask you to speculate on what your theory is and whether we should design an experiment to try to test that. Here's another example, purple finches and house finches, which we're familiar with. We've lost 47% of our purple finches in the last 50 years. If you look at the chart over on the left, this is also from the Breeding Birds of Minnesota. You've seen a pretty drastic downward trend. So 1.7% decrease year over year. We think it may be in part due to competition from house finches, which are more aggressive. You can see the house finch trend because they were an introduced bird. We first started seeing them really on the uptake in Minnesota in the late 1980s. In fact, we banded our first one at Carpenter, I think, in 1990. They exploded due to the introduction. And then you see this decline here due to conjunctivitis. So what would you expect would happen to these two species in our banding at Carpenter? Well, this one has two different birds on it. You can see the purple finch is in the orange here. Actually, the trend in purple finches has been that we've seen banded has been very similar to what the breeding bird of Breeding Birds of Minnesota estimates. And the house finch does the same thing. We grew very rapidly to this peak, probably through conjunctivitis declined, and now have a pretty steady number of house finches here. So looking at these species, just looking at new bird data, we can see that in this micro environment, in some cases, we see very different trends from what's going on nationally or within the state. In other cases, we see very consistent trends with what's going on. Now, I want to talk about something that I call the Junco disconnect. I mentioned at the very beginning there were some very active banding sites in the state in the 1920s that Roberts talks about. In the very, very rural part of Hennepin County, just north of Lake Minnetonka in 1923, F.W. Commons and his wife started a banding station, and over the course of about 8 years, banded 18,000 birds of 97 species. So a very successful station. But over that period of time, with 3,491 juncos banded, they had only 2 re-encounters of dark-eyed juncos. So only 2 birds found their way back and were captured a second time. If you look at the data from Carpenter over 45 years, we've banded about 32,000 birds of 150 species. We've banded 8,700 juncos, making us probably one of the biggest junco banding sites in the country. But we've had 2,800 re-encounters. So when I say the junco disconnect, I have to ask the question of what's changed. Why would the F.W. Commons site with 3,400 birds banded only have 2 re-encounters, and at Carpenter we have really 3 orders of magnitude greater than that? I think it's worth perhaps designing an experiment, trying to understand what's going on there. I know I only have a few minutes left, so we're going to look at just some re-encounter data that I found a little bit surprising that I think you might find interesting. These are the top 11 birds that we banned at Carpenter. You'll see in the first column, it's the number of new bands for these birds over 46 years, how many birds have been re-encountered, and the percent of re-encounters of new bands. So if you look at the chickadee here, 138% re-encounters means that we re-encounter a chickadee an average of 1.4 times. Now we know that chickadees cache food, they're local all year round, so it makes sense that we would have a high re-encounter rate on chickadees. Similarly, white-breasted nuthatches down the list here. We know that nuthatches defend their territory year round. And so it makes sense that for the nuthatches that we capture, that we would have high amount of re-encounters. But there's also some really surprising numbers here. Tree sparrows, which are only here for a brief period of time, we see an astounding 63% re-encounter rate. And juncos, which I mentioned earlier, 31%, which is also a pretty high rate. If you look at another resident species that supposedly lives here year-round, the house finch, we've banded almost 1,600 of these. We've only seen 2% re-encounter. So what's going on here? Why are house finches, do they have a high mortality rate? Do they just get really smart and avoid the back of the net? Or is there something else going on? It's these kinds of insights that once we started putting re-encounter data into the database, started opening our eyes to some of the unusual things that were going on with some of the bird species at Carpenter. I'm not going to go into a lot of detail on this. This is just some surprising re-encounters of black-capped chickadees. As I said, we banded 2,500 of these birds. Almost 60% have never been recaptured. 399 of these birds have been recaptured once, but you look over here to the right side of the chart, we've had chickadees that we've recaptured 18, 20, 21, and 22 times over a period of a lot of years. So might be something to learn there. The chart looks about the way I would expect it to, but it's just good to have this kind of data to be able to see what's going on with banding. So in spite of technology, we know that this ancient practice of banding gives us great insight over time. Scientific data is critically important to the long-term survival and abundance of birds. And banding stations are actually used by scientists to do things like collect excrement and feathers and parasites on known birds. It's banding stations that are required if you're going to do things like nanotagging birds or installing radio transmitters. You can't do that without a banding license. So the new technologies do rely heavily on banding stations to capture age and sex birds, to help them design experiments, and to deploy the technology. A lot of those scientists don't have the money or the people resources to employ a significant amount of the new technology, so they still rely very heavily on the data from these banding stations, the old-fashioned kind of banding with the metal rings to gather their data. I would say that all of the banders out there deserve our recognition and respect because they are advancing natural history knowledge. They're helping us understand environmental impacts on bird populations. They're helping us understand impacts of climate change, agriculture practices, development, water quality, and many other variables on bird populations. So I would suggest that if you're looking for a citizen science opportunity, a really, really good citizen science opportunity, I would encourage you to visit a banding station. Ask if you can volunteer. You may not actually be banding birds, but there's a great number of different activities that you can do. Bird extraction, data entry, data analytics. And I promise you, you'll be rewarded with access to some of the best bird scientists in the state. You're definitely going to learn a lot, and you'll help the birds, and hopefully you will bird with a purpose. Carpenter Nature Center does have public banding every fourth Friday of every month. So if you're interested in learning more about what's going on with banding, we'd love to have you come out and visit us, and meet some of the great people and learn a little bit more about what this is all about. So with that, if anybody has any questions or comments, or some of your theories on what's going on with our data, I'd love to hear it at this time.
Yeah, but we do have a few questions, Randy.
Yeah.
Annie was asking, was the US the first to set standards for bird banding, and do other nations use similar banding practices as the US? She said, I know it's called ringing in the UK.
Yep. Bird banding is done around the world today. Of course, the level of maturity in different areas is very, very different. Some areas of what I would call maybe more emerging countries where bird watching has not been popular for very long, could be pretty elementary. But certainly throughout Europe, they've been banding for a long time. Throughout Canada, they've been banding for a long time. And they do use the same practices that we use here. There is international sharing of bird results. So the US and Canada have an agreement to share results on North America birds. I don't know if that adequately answers the question, but yes, the same practices are used globally.
And then Joan said it's harder to get birding permits than it used to be. Are there fewer stations than there were in the past?
I don't know the answer to that. Jen, if you're on, maybe you know that. Jen is our permit holder for the banding station at Carpenter. It is hard to get a banding permit, and it's even harder to maintain one. You have to do everything right. Jen, I don't know if you have any insight as to how many permit holders there are and whether it's increasing or decreasing.
I'd have to look at that. I do think it's not a bad thing that they're being more stringent in giving out the permits, because now you can get so much more information about migratory connectivity, longevity, and all those questions due to all these new technological advances. But I'll have to look into if there's more than there used to be. My guess is there are probably more, just because it's, with our communication era, we can share a lot of that. And it looks like Danny had a fun fact. Japan created the first mist net, and we started using them in the 1950s. And we
Wow.
love the Japanese mist nets at Carpenter. They're very well made.